Colors, we see them every day, but what determines the color of the light? Is it the frequency or the wavelength? Let's find out. Light is an electromagnetic wave, and just like any other wave, it has frequency and wavelength. The wavelength of light is the distance a wave travels in one cycle. It is represented by lambda. Frequency is basically number of waves passing through a point in 1 second. For example, if 3 waves are passing through this point in 1 second, then frequency is 3. It is represented by mu. The spectrum of light shows the values of frequency and wavelength for different colors of light. For example, as you can see, red color has a wavelength of 700 nanometer and frequency of 429 terahertz. Similarly, blue color has a wavelength of 400 nanometer and frequency of 750 terahertz. You clearly see that the longer the wavelength, the lower is its frequency, because if a wave travels longer distance to complete a cycle, that means there will be less number of waves passing through a point in 1 second. Therefore, frequency and wavelength are inversely proportional to each other. They are related by this expression v is equal to mu lambda, where v is the speed of the light and its value is 3 into 10 power 8 meter per second in vacuum. Now, how do we actually see the color of an object? Let's take an example of Deadpool's suit. The white light, which is composed of all the colors, first falls on the suit. Except red, all the remaining colors gets absorbed by the suit. This is due to the chemistry of the compound the suit is made up of. Hence, only red color is reflected back into the eyes, so we see the suit as red.
Well, what about this black area?
Oh, in that case, all the colors of white light gets absorbed and none make it to the eyes, so we see it black.
That's sad. Hey, what about this guy over here? Looks like he's shit in his suit.
So you think the answer to the question is both a frequency and wavelength, which determines the color of the light, since they are dependent on each other. But I would like to give you one more perspective which actually shows is the frequency which determines the color of the light, not the wavelength. When light travels in a medium, its speed will be reduced as compared to its speed in vacuum. This is because of the interaction of the light with matter, causing the light waves and matter waves superimpose. This causes the slow down effect of light. Since frequency of light cannot change in this case as it is decided by the source which is producing the light, so a given source of light will keep producing a defined number of waves in 1 second. Hence, from this equation point of view, if the speed of the light decreases in a medium, its wavelength should also decrease to compensate, since frequency remains constant. Thus, the wavelength of the light in different medium will be different. Now we'll see how does this affect the color which we perceive. The reflected color of the light, let's say in our Deadpool example, be red. When the red light enters the eye, it passes through the eye lens and finally hits the retina, where there are light sensing cells, rods and cones. Wonder why they are named so? Which picks up the light waves, gets activated and sends signals to the brain, which is how we perceive color. Now, before these cells pick up the light waves, there lies a gelatinous medium between the eye lens and retina called as vitreous humor. The light in this medium would not have the same wavelength as in vacuum. Therefore, the wavelength of light changes in this medium, but still we perceive the color as red. Why? Because the frequency does not change, and that is why it should be more fundamental character which determines the color of the light. I have posted the same question under the community tab, but unfortunately many of you have voted the answer as wavelength. What is even more unfortunate is hardly 10 to 12 people have voted. I'll see you in another video.